The third iteration method we will talk about is called the successive relaxation method. Successive relaxation method. And this is the last iterative method we will introduce, and this method is built on Gauss-Seidel. Built on Gauss-Seidel. Okay. So you have the successive relaxation method. We can call it SR method. And that is basically get a balance between your previous results and the current result. So the key of SR method is the new iterative value will be equals to 1 minus omega times xk plus omega xk plus 1. So this xk plus 1 is from Gauss-Seidel iteration. And those are just, previous values. So this omega is called relaxation parameter. And if my omega is equals to 1, then this part will be 0. You will only have xk plus 1 from Gauss-Seidel. That means if omega equals to 1, that is leads to the Gauss-Seidel iteration. But if my omega is over 0 smaller than 1, that means you take some portion of your old value and some portion of your future value, right? The new value. Then that will call it under relaxation. And this have the shortage. Basically, if your Gauss-Seidel is very good iteration for this system, then it will converge slower. Okay, so this is note. If your Gauss-Seidel iteration is good for the system, then by using this omega parameter is over 0 smaller than 1, you will slow down. You converge. You slow down the converge. Then there is also another choice you can choose is omega is over 1 smaller than 2. That is called over relaxation. So you take more part from the future new value, and you take negative portion of your old value. That is called over relaxation. If you have over relaxation, usually the good choice for the omega is around 1.5. And really, this is depending on the problem. So the omega, you need to run in a loop, trying to see for this system, what kind of omega is the best for this system. So you need to benchmark from yourself regarding the value of the omega. But usually, if this is an over relaxation problem, a good choice, we can start with 1.5. But it's still, let's say, depends on system. And we will show examples using